Hello everybody, and I'm gonna talk here about multi-master replication for fault tolerance. That's the work done by Postgres Pro team. Me and several of my colleagues, we are working on that for about a year right now, and we want to show what we have so far. So I'll talk here about actually what's multi-master replication is and what we are doing. So I use kind of a lot of buzzwords and presentation names. So I'm doing like A/B testing of what words attracts more listeners to presentations. So short intro. What is it? So first of all, multi-master is a replication. So you can set up several nodes and the data will be the same on all nodes. We're enforcing cluster-wide transactions. So there is no conflicts between writing to each node. The resolution of conflicts is the same as the resolution of conflicts in several backends of standalone Postgres. So your transaction will have the same snapshot on all nodes, and we are intending to OLTP load, so it's kind of OLTP friendly. So you can do a lot of transaction. It actually confronts that clusters made for analytics when the expected transaction rate is low, and you can actually do a lot of things to get a snapshot. And we are trying to avoid that, so we'll be able to run a lot of transactions per second. And the cluster will be alive while majority of nodes are alive. So the same guarantees that use most of the replication algorithms that helps you to survive network partitions. So okay. We can also add node to the cluster on the flat without stopping, or if some nodes goes away from a cluster due to failure or network partition, it can be automatically inserted into a cluster. And yeah, we are more or less compatible with standalone Postgres. I'll talk about differences. And actually, I want to stress what it isn't. It's actually not a sharding solution, so the data is the same everywhere, but you actually can specify some tables. It's a replication done on table level, actually, as in the PGLogical. It's based on PGLogical. Yeah, you also will not scale your writes because, I mean, you are writing the same data to several nodes. And in best case scenario, you will just wait for a slowest node. And it's probably not the best choice for geographical replication. So it's a multi-master, but it's strongly coupled multi-master. It doesn't allow conflicts. And that's why it will be like increase the latency of commit a lot if you are doing geo replication with that solution. Probably for geo replication, it's better to use something like BDR if you actually can force your application to use BDR. Okay, so what's the main idea to create a solution with Postgres that can handle automatic failure recovery? In a usual Postgres, we have like read-write master and probably several read-only replicas. And in case of failure, that nodes can fail, and somebody, it can be a person like sysadmin, can promote this replica, and after that, all clients can go to this read-write replica, all writing clients. And there are some questions about that. Who will do that? There are some external tools. I think Josh will be talking about several of them. And how these tools can be sure that that node is actually dead. Because if there is a network partition between these nodes, you can end up in a situation when both of these nodes think that they are masters and accept writes, and that's actually bad situation. It's called split brain. So what we want to have is something like that, when all nodes talk to each other, and in case of failure, it just continues to work. Some time ago, like long time ago, Postgres didn't have any replication solution inside, and a lot of people were creating replication based on scripts, on something else. And I can compare this situation with the replication. So right now, a lot of people doing their own scripts to do a failover. And what we want to have in capabilities of that failover in core. So let's talk about some design objectives behind that. If we are going to see on different clusters, clustered database generally, we can identify two big branches. So one of that created for analytics and for transaction processing. And if we go to analytics, there are actually a lot of clusters. So even based on Postgres, there is a Greenplum, Vertica, and a lot of them. But if we are going for OLTP style loads, there is actually not that much. There is a VaultDB, there is a Galera replication for MySQL, and most of the NoSQL database, not most of them, but some of them are targeting that area. So you can create like high available backend for your web service with NoSQL. So we are targeting that quadrant too. And replication itself. So we need something like Peter already told, that allows us to replicate data. Also, we want to do it on a table level and allow writes to any node, as I said. As we allow write to every node, we need to have some way to ensure that isolation between transactions is properly guaranteed. There are some algorithms on the market to do that. Mostly Google released, Google and Microsoft research go into that direction. There are database actually called Spanner that used internally in Google, and CockroachDB. It's kind of open source version, with slightly different algorithms, but they actually do not require atomic clock. But Google inside use atomic clock to ensure consistency. And also paper by Microsoft Research called Clock Snapshot Isolation that we're actually using inside Multimaster. To avoid single point of failure, we need to do transaction management in distributed fashion. So most of the analytical databases, they just set up a different node. And when you're starting a writing transaction, each node goes to that standalone transaction manager. And that transaction manager actually can be a single point of failure. And sometimes in some database, it even goes to transaction manager for read-only queries. And we also want to avoid that. Another story about how to proceed with fault tolerance. There are some algorithms on the market. Most notably, everybody excited right now about Raft. And it's actually quite a complete replication solution with heartbeat included and automatic recovery. But it proxies all writes to one node, so it's not very we cannot quite easily insert that in a Postgres replication, because we need to wait to proxy write-ahead logs in that way. But what Postgres already have, it's two-phase commit, and Postgres already supported, but it's in the sense of distributed algorithm, it can actually block. If some nodes go away from a cluster, we can end up with some transactions that we don't know what to do with them. they can be prepared, and due to some node failures, we don't know what to do with them, commit or abort or whatever. But happily, we can insert one step between prepare and commit and two-phase commit and end up with a lot, different kind of algorithms about commit. It's three-phase commit, paxos commit, E3PC, and there are some theorems that prove that paxos commit and E3PC do not block the cluster. So, but actually 3PC is blocking. There is kind of one situation where it can block, but all that algorithms in the sense of communication delay are the same. So you will wait. You need to wait like 2 round trips. I'll show it actually. So summary: no or small penalty for reading transactions. We can write to any node, and in case of failure, while majority of node is alive, we can proceed. So, what we have so far is that is linked to our GitHub page. It's a patched version of Postgres 9.6. We tried to minimize patches that we need to push into our core, and we actually hope at some point in time that will be pushed. Mostly changes about like transaction manager inside the Postgres. We insert some hooks there, and about logical decoding of two-phase transaction, because we rely on that, and PGLogical doesn't support it yet. And also it's an extension. We have implementation of transaction manager there based on that Microsoft research paper. Logical replication client, and some other stuff that we need to proceed with that. So, yeah, as I said, we are using logical replication by second quadrant. It's actually, they did really great job. And there is a way to send like logical messages through a replication. So some writes to xlog that not visible on your tables, but you can create some distributed algorithm, use that as a communication layer. So here is the main like work line for our commit procedure. So there is two nodes, one that we are connected to, and cohort of all nodes. I draw here one node, but actually that means all other nodes. And there is some bunch of background workers. On our node, we're interested in backend, that client connected to wall sender that sends log to other nodes, and arbiter. Arbiter is our custom background worker that counts votes for transaction or against transaction to proceed with 2PC or 3PC procedure. So client sends a transaction and types a commit, and here we hook our extension and transform that commit to actually prepare. So all commits explicitly translated to a prepare. After that, while sender starts reading it and sending to other nodes. That actually can happen before commit happened, because it's while sender starts asynchronously. After the cohort applied, each of nodes sent prepared message if they actually were able to prepare that transaction. They can be, for example, abort due to parallel activity on the server. After that, arbiter counting votes. If all other nodes voted like, yeah, I can prepare, we write intentions to all other nodes, and that step is needed for case of failure. So if our node will be dead and all nodes that we are sent commit is dead, in 2PC scenario, we can't actually resolve that situation. But with that intermediate step, we write intentions to all nodes, and after that, all transaction can be committed or aborted based on timeout. So after all pre-committed messages also collected, we can do an actual commit and response to a client. And we even do not need to wait for that commit to propagate to other nodes, because even if that message will be lost, there is enough information on nodes to proceed with that commit. So the transaction manager itself. So here I described how algorithm works about ensuring atomicity of transactions. If we will add some information about snapshots to that messages, we can also have a proper isolation of transactions. So it's a basically clock SI algorithm. There is a research paper with whole way to implement that. If somebody is familiar with the Postgres way of assigning a transaction, it's actually make use of commit sequence numbers instead of running lists like in Postgres. And right now some patches by several developers propose it to have that CSN in core, mostly because it improves performance on multi-core systems. But that's kind of a lot of details. Okay, so also we did the DDL replication, and we put a lot of actually work to be totally compatible with Postgres. It's actually done on statement level. So when you type into your Postgres instance something like create table, it starts a two-phase transaction, replicates that text of the DDL to all nodes, applies it, also account like votes if all nodes can apply it. And yeah, that's how you proceed with DDL. And there are some really strange, not strange, but hard things to proceed with that way in Postgres. For example, create table as and create materialized view. They're writing both to a table, user tables, and also to a catalog. So you need to filter out table writes so you will not replicate the same data twice. So if you, for example, replicate create table as and apply it as a text, and after that you will replicate data itself, you will end up with a situation where it's like all your data on cohort is duplicated. So we are kind of handling that situation. Also, temporary tables, we deal with that, and we also pack all environment variables along with that DDL replication, because it's actually with variables you can influence a lot what you will do with DDL statement. For example, changing sort path or aus, you can end up with total different behavior of replication, DDL replication. So right now we are passing almost all Postgres regression tests. So that more or less means that you can run application on multi-master as it in a Postgres. There are some strange scenarios in a Postgres regression test that we don't want actually to fix. It's totally possible to fix them, but just we want to leave it as is. Because one test is using prepared statement inside create table as, and prepared statement is something local to a backend. So, I mean, better don't do like that. Several tests using like create table as, based on create table as, and of temporary table. We are skipping temporary tables in replication, and we can identify that second create table as using temporary table and stop replication for that one. But we can't actually identify create table as like in a third dependency, third level dependency. We actually also can have some lists to do that, but just we decided that better not to do it. Okay, so let me show how actually recovery works. In case of some problems with the network, for example, we have cluster of 3 nodes, and suddenly network stopped stopped working for a node 3, but node 3 is actually working itself, so it should stop receive writes. We have a daemon that sends heartbeats, and on heartbeat timeout, this node will stop having writes. Before that timeout, actually, all transaction will stuck because every committing transaction need to collect votes, and since there is no network connection, all transaction just will stuck here. And after some timeout, that node will be pushed away from a cluster, and that two nodes will continue to work as a cluster of two nodes. And there is kind of write-ahead log streams. So at some point in time, write-ahead log for node 3 stops, and two other nodes are proceeding. So when that network failure is over and network is started working as usual, third node connects to a random node. Here it's node 2, and started replication from node 2 to start grabbing all the data that happens since time of failure, and that happens till the some amount of time or x logs. Actually, that's a configuration parameter. So that node will replicating data until, for example, last 10 megabytes, because actually there is kind of simultaneous writes on these nodes, and probably in this scenario, node 3 will never keep up with that updates. After that small kind of distance is finished, we issue a lock operation from node 3 that locks node 1 and node 2, and all committing transactions also will stack here for a small moment of time while node 3 recovery till the end of xlog. And after that, it just switched to a normal work, and actually all the things happens transparent to user. Only thing that you should be aware of, like if that situation happens for a long period of time, like while senders will be really big here and here, so you need to kind of do something with that. So what about configuration? It's actually just about installing extension, and we need several configuration options for Postgres to being able to execute that extension. So mostly we need to enable prepared transaction. By default, it's switch it off in Postgres. We need a logical level of write-ahead logging. We need several background workers, and actually we want that our extension will be loaded in a boot time. And after that, just configuration of multimaster, just specify all connection strings to all other nodes and specify node ID for that particular node. So connection strings will be just the same on all nodes. I mean, if you like opening ports in a usual way. But node ID should be unique to each node, like 1, 2, 3. And
these parameters that you showed here, they're all from 9.4 onwards.
What main?
These parameters are available from 9.4 onwards.
Main, I didn't hear.
Postgres 9.4.
Postgres 9.4. Actually, these parameters, I think. I don't remember about Postgres 9.4, but anyway, you will be able to run multimaster only on our patched version of 9.6. So Mike. What? So the question why we need logical. Okay. But anyway, to run multimaster, you need that patched version of Postgres, and it's based on 9.6. Yeah. So we hope to post the changes to a Postgres community that will be accepted to a mainline Postgres, but right now it isn't. So only option to run multimaster against our 9.6 version.
But
Right now, right now only option is that 9.6, but in theory it's logical replication, and you can have in a cluster different nodes of different versions, so it's totally okay. So, testing. I just see how much time I have. Okay. So, big problem here is how to test all that stuff that's happening with a cluster. We want to test it against no network problems, against shutdown, restarts, time shifts. Most popular things that you can see on internet is a Jepsen, but it's not a good fit for doing testing while you development, because it's use just this SSH connection to a pre-existing machines. And there is a framework, TAP framework, inside a Postgres core, but it spin up a cluster by using several processes inside one operating system, assigning different ports to different PostgreSQL. And there is no kind of really simple way to test for network partitions in that scenario, because you have to control somehow how operating system assigns new outgoing ports. So what we are using actually, that's Docker and Docker Compose, and we inject failures to each of Dockers. By using Docker exec, we can switch off network, shift time, restart Postgres, and actually it's compatible to a lot of continuous integration tools that you can actually start it quite fast. So tests itself is right now that strictest test that we have, it's a banking test. So attach a client to each node of the cluster and start transfer money from account to account, and simultaneously run some analytical query to ensure that proper isolation is enforced everywhere in a proper way. And while we are doing the test to each node, just starts injecting failures, like start stop node, kill nodes, do a partition. Also, quite important case that calls majority rings. It's just a network split between two, remove edge on a graph of connectivity, and when in that manner that each of nodes sees majority of cluster, but there is one graph, one kind of connection isn't working. For example, node 1 sees node 2, node 1 sees node 3, but node 2 doesn't see node 3. And each of nodes can have a majority, like it sees at least 2 nodes. So that scenario kind of should be handled differently than just a network split. Also shifting time, because clock SI actually dependent on local time. It doesn't depend on time synchronization between nodes, but it does dependent on local time. Okay, so performance. More or less all performance impacts is due to commit takes more time. You have to wait 2 network round trips. And if you are having your setup inside one data center, you actually can evaluate how that happens, how that impacts your load. Inside one data center, that can be actually more or less the same performance as a standalone Postgres for both read and writes. But when you're starting replication between nodes that are geographically distributed, it becomes worse and worse, because commit latency is increased. Also some issues with logical decoding itself, but there is a work to improve that. And our roadmap is to release a public beta during this New Year holidays. It will be available builds of 9.6 with that extension included. And try to commit all that our patches to a mainline Postgres. Probably it will not happen to a Postgres 10, but after some time, we hope, at least we want to work on that. And also we need to raise some discussions about how to proceed with DDL in such environments. It probably will be beneficial for all guys who are doing clusters on top of Postgres, both BDR and our multi-master and all that stuff. So thank you. That's it. Any questions, suggestions?
So if I want to add a new node to the cluster, how does that work?
Yeah, it's works more or less in the same way. You just have to copy one node. For example, you want to add new force server in that setup. Just copy data files or to that new node from any of the nodes, and after that you can reconfigure cluster to, write connection string with alter system to one node, and after that it will propagate to all other nodes, and that node will actually enter the same way to that cluster. And also it's actually when it's even number of nodes, you actually don't need, strictly speaking, but you want probably to have special flag on one of the nodes to broke the symmetry. If the nodes happens if network splits happens in symmetric ways, that two nodes from one side and two nodes from other sides, there is no majority and it should stop in that way. But there is a way to handle that situation if you give a flag to one random node during configuration. One of the sides of that partition will have that flag, and it can actually proceed with receiving writes.
If you are adding nodes based on the workload on the application, say suppose I have big application which is accepting connections, 800 connections per node, I have 2,400 in case of 3 nodes, right?
Mm-hmm.
So if my connections are exceeding 2,400, I want to send one more machine, and which can be replicated and do that how long will it take for 40 data?
So the question is how long it will take to new node to be available to accept writes? Mm-hmm. It actually depends on your writing scenario. It depends on how quickly that node can feed up all the data that happens between the time that when you copy data and the time that you're actually switching it inside. More or less, if you have normal pattern, you're not doing tens of gigabytes per second, it will be quick enough.
And what in these two pictures you talk about the point where in the first point the red dot
Mm-hmm.
is configurable.
It's configurable. By default, it's a configuration parameter in megabytes. So we are replicating all data until it's about 10 megabytes enough, 10 megabytes till the end. And after that, here will be log. More or less, 10 megabytes replication, it's less than a second.
So immediately the lock will get applied.
Yeah. So that is kind of short-lived log, short-living log.
Is there any network latency requirements between these nodes?
Network latencies?
Network latency requirements.
No special requirements, but you need to be aware that each commit will wait to two network round trips. So inside one data center, it can be really less than 1 millisecond network round trip, and it will not add like big penalty because of like commit itself takes several milliseconds. But if you are doing geographical replication, you should be aware of that. So if one server in the US, one in the Europe, you will add like hundreds of milliseconds to a commit.
Can you compare that to the standard replication?
In standard replication, you can write only to a master node. That's the one point. I mean, all replicas is read-only.
So you still have a round trip, so you only have one.
Yeah, depending on synchronous and asynchronous mode. If you are using synchronous, you actually waiting for one round trip. In our scenario, you're waiting for 2 round trips because that intermediate step. Yeah, sure.
So if a node has been cut off from the other nodes,
Yeah.
and is therefore in catch-up, it's not accepting writes,
Yeah.
is there, what's my easiest way to detect that the node has gone into that mode?
There is kind of SQL functions.
Yeah, okay.
We just add that in our Grafana template, monitoring how many nodes available, and actually also important things to be monitored that kind of lag. So if node out for like several days, probably you want just to kill here and here replication slots, not to bloat your disk, because it will store all logs that needed to be applied here.
Okay. So you rely on replication slots, yeah?
Yeah. We don't restart them, just
How do we manage that distributing the application load onto different databases? Here you have your
for example, HAProxy, HAProxy will work in this scenario. And the easy things here that each nodes accept writes, so you don't have to bother like distinguish between read-only transaction and read-write transaction. So you just can randomly schedule that. And in case one node is gone, HAProxy can throw it away.
So
Yeah.
in case of the write transaction, write commit, in the prepare and pre-commit, are you waiting for all the nodes to respond, or
Yeah, actually we have like two barriers here. First barrier that all cohorts should respond with a prepared or aborted, and if that's prepared, again all cohorts should respond with pre-commit. So through 2 round trips you should wait.
So this sounds very similar with Greta from
With what?
Greta from MySQL World, the multi-master cluster. So can you compare the
Yeah. It's actually quite a different under the hood, because Galera actually the difference here. Galera actually enforces write-ahead logs to be the same on all nodes. It's actually the same sequence. And that qualification of inserts to xlog happens during the write. And in our scenario, we actually do not force xlogs to be the same. And that's one of the reasons why node that is going into a cluster should only replicate from one node, because xlog actually are different here and here, order of inserts there. And that's why we should enforce like transaction isolation, because like writing backends on all nodes can influence your transaction. So like speaking short, it have different like penalties. Insert will be faster in that scenario. I mean, actually insert faster in Postgres itself than in MySQL. But anyway, like these algorithms allows you to do inserts faster, because there is less like less locks during writes, let's say it that way. Yeah.
This locking, this replication is streaming replication or the while replication?
That's a logical replication. Yeah. So if you were here before when Peter was talking, it's the same logical replication. We use custom client, actually modified PG logical to implement all that stuff. Yeah.
And whatever the rules applicable for PG logical will get applied.
Not strictly, because I mean a lot of things in PG logical relies on that conflict resolution, and in our scenario, conflict resolution rules are totally different because we enforce snapshot isolation cluster-wide. More or less, you whole cluster acts as a one Postgres. Yeah.
How easy is it to take a node out of the replication? You use like node 4
Just kill -9. That's all, yeah. I mean, you actually can, again, you actually can abuse the node in arbitrary way. Just switch off power to that node, and two other nodes will just okay with that, unless majority is alive.
I'm talking about a scenario when I have a software deployment.
Mm-hmm.
I want to test it just on one node, and if it's successful, I would like to propagate it across all the nodes.
That's, I mean, the idea is that data is here everywhere the same. And if you want to test it on a one node, I mean, it should be.
Yeah, then that node wouldn't be able to rejoin.
Yeah, totally. I mean, if you will do split brain between like one part of the cluster and different part of the cluster, it's something like wrong. It's, I mean, actually, if that node's taken away from cluster, it will forbid any writes. Any writing load will be forbidden. But if you actually, I mean, if you attach with a GDB and put some flags down, you can do that, but you will fail to rejoin it. Actually, I don't think you will fail, but you will just lose all your data that you wrote here.
But if I apply the same changes to the rest of the nodes, right?
You don't have to. When you applying some changes to a node, for example, 2, it's automatically, even before you answer it with a commit, it's on all other nodes. So it's the same data everywhere.
Even if you add data, it will rewind back to where it was before?
What?
When you go and add data to the third node because of my test.
Yeah, it's
Rejoin them.
if you written some data here, I mean, it's hard to write data here because normally that node will not accept any writes if it can connect to other nodes. If you have that multi-master extension loaded, it will just stop you from doing that.
So it is 100 until reach to the 100% of connectivity, it won't accept any connections.
If that node is taken away from cluster, it will accept connection, and by default it will allow reads, but not writes. And you actually can force that node to stop even reads. It's depending on your application.
But when the node is available, when a HA proxy is able to identify the node, then how the read, we can
Yeah, you can.
store the writes, how can you stop the writes? Application will have to see the failures also, right?
Yeah, but you probably on node failure you want to update your HA proxy configuration to stop scheduling transaction here.
Can we do that? Like, do we have any setup like to reach 100%?
There is several SQL functions, so you probably want to have some monitoring that will update HA proxy. So we do not provide any standard proxy configurations that will do that. Other options that we actually want to deploy with that using several connection string in a PSQL library. So right now I think it's already committed to a Postgres, so you can in your connection string specify several connections, and when that node stops connection, just all clients will reconnect to one of that. So even without HA proxy. Yeah?
I wanted to offer another suggestion, which is one of the things I'll be showing this afternoon is how you can automatically update DNS discovery, so that what happens is the non-responsive node gets taken out of discovery, so new connections won't be made to it.
And there is no limitation to have the odd number of nodes for communicating, like in case if it is an even number of nodes, like 1, 2, 3, 4, if the network run between 3 and 4 forming one cluster and 1, 2 are communicating, then how is that situation handled?
So if inside any split you have a majority of nodes, it will work. If there is no majority, if you like split it in that way, there is no.
So 4 nodes are there.
Uh-huh.
1 and 2 is.
Yeah, you mean symmetrical split.
Yeah, vertical.
Yeah, there is special configuration parameter. You can give a special flag to one of the nodes, specifically for symmetrical scenarios. For example, 2 nodes. You can give a flag to one node, and in case of network split, node with flag will continue to work, node without flag will stop working. That. I think time is up if somebody wants to ask.
Yeah, you actually still have like 5, 10 minutes.
Okay.
Yep.
Okay. Okay, 5. Sorry. Yeah.
What sort of network topology is used for the communication between the different nodes?
All nodes connected to all nodes. So probably it can be a problem when you have a lot of nodes connected in that way, but since it's all data the same on all nodes, probably, maximum of what you want is 5 nodes. I don't have like really viable scenarios when it's more nodes. If we will go to like boiling down that for a table level replication, so for example, you have like totally different Postgres installations, and you want to replicate one table, probably it should be switched to something else like gossip or whatever. But right now, just any nodes connects to all other nodes.
Can we use the private connection, private network connection between the nodes to read out the application requests and the database communication?
Private, you mean like?
Like having separate network switch and network.
Yeah, actually, connection strings is just Postgres constrings, and you can have like any port that you want. For example, you can have a firewall redirecting from one port to a different port, so it's not a problem.
Just the Ethernet 1, Ethernet 0 might be for all nodes to private network, and Ethernet 1 will be the public network.
For example, yeah, it's configurable.
So, what are the odds that the patches you need are going to be in 10?
I think the patches about two-phase decoding have big chances, because more or less there is no kind of, guys agree that it just should be done. Patches about transaction manager, more or less, there are some agreements that it should be committed, but it's not clear in what shape. Whether we want just API or we want some standard reference implementation here. There is interest, but it's probably like in an optimistic scenario it will be an 11. In realistic, just something after 11. But we will try to push it in 11.
Okay, so you're not even going to try to push it for 10?
Yeah, we will try. We will start trying to push it for 10, but probably it's not gonna happen for 10, because it's really a lot of things. And guys who are writing Postgres XC2 from Entity, they actually, they want quite a different transaction manager insights that we are imposing. So we are doing transaction isolation in totally distributed fashion. And PostgreSQL guys, they actually want to have a standalone GTM because of overall network communication. Amount of network communication is less when you talk with one node. But yeah, so probably it will be hooks and some standard implementation of transaction manager, and we need to actually to change visibility rules, all that stuff. It also depends on commit sequence number patch by Heike. So it's quick, quirky.
Query execution time will be more compared to the distributed case here. So there you are splitting the request to multiple
Yeah, so
tenants there, and here you have everything to one database. That database has to run for the whole table and then return the request. Here you have the memory consumption of like different way. There it is like you are splitting multiple processes and representations, right?
yeah, and the question is?
So question is here the query time will be more compared to the.
So query time, if you are writing some data, there are two things. First of all, you will apply the same data for your node, local node. After that, you have to wait while remote nodes are applying the data, but it happens asynchronously. So actually, the decoding starts before you even commit it. It's one thing. Another thing that just commit latency because of round trips will increase. For a read-only transaction, you just reading a local node, it's more or less the same, except there is an intermediate step in a commit phase. So in that transaction manager, we have intermediate step between running transaction and finished transaction. There is also a in progress, and when you're reading something in progress, you should wait. So it actually readers can be blocked for a short amount of time. Because in Postgres, it's just done atomically to a PGC log by setting up 1 bit, so it enforces that it's really atomically. In distributed scenarios, you should actually have some intermediate step and wait, because you don't know whether it's commit or aborted. So it actually can slightly decrease speed of reading transaction. Yeah, so 1 minute. Yeah, so thank you.